Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the rearrangement reaction. There we have considered some of the example. So what are the mechanism involving the carbocation? That is the point we are discussing, and I think so far we have learned 2 or 3 example of that one, how the mechanism, how we are getting the unexpected product or the rearranged product. Atoms are generally get rearranged in the special arrangement of that atom. So that is we are discussing. What we are going to discuss right now, remaining example we are going to discuss over here. So what are those? Let us see over here. I think first one we have seen, first 2 or 3 example we have seen. Now let us take the another example number 4. Example number 4 over here. Now let's see what is that. Suppose we have this compound, then there is a Br, right? So this is the starting compound, and this will be treated with alcoholic KOH, alcoholic KOH. Elimination reaction takes place over here, elimination. And as we know that elimination means what? In a reaction in which an atom or group of atom are removed to form a higher degree of unsaturation is known as a elimination reaction. If elimination reaction takes place, it gives 2 type of the product, 2 kinds of the product. Double bond over here, another one we are getting here, this type of the 2 product we got. If you see over here, what would be the starting material of this compound? Can you tell me the IUPAC name of this starting compound? Look at here, 1, 2, 3 and 4. You can go this way or you can go this way. That is you have to select the longest continuous carbon chain and see what are the element present over there. If you see over there, that is a 1 bromo, 3 methyl, 1 bromo, 3 methyl butane. That is a IUPAC name of this compound, the 1 bromo 3 methyl butane. And after the elimination, and as we know that alcoholic KOH and the aqueous KOH, there are 2 solutions generally we are employing in a reaction. If you use this alcoholic, this word is a very important as far as organic chemistry is concerned. Suppose if there is a aqueous KOH, if you use it, so what is going to happen here? Aqueous KOH, it will the reaction there occur as a substitution reaction. And what do you mean by the substitution reaction? The resulting compound you are going to get here is a OH, right? Substitution reaction means that bromine compound get substituted by the hydroxy group OH, and this type of the reaction is called as a substitution reaction. A reaction in which an atom or group of atom get replaced by the another atom of the reagent used is known as a substitution reaction. So this reaction is known as a substitution reaction. In the substitution reaction, no rearrangement reaction occur. Only this Br get replaced by that one, and we are going to get as a different product. Now we are talking about the reaction or the mechanism involving carbocation. As we know that mechanism means what? A detailed study of sequence of steps which are involved in the conversion of reaction into product is known as mechanism. So here this we got as a, if you see, can you tell me which one is a major and which one is a minor? Yes, this one is a major and this one will be the minor, right? Why this one is a major and that one is a minor? Do you know? Yeah, this is a major obtained according to as a CH-3 rule. Have you heard about that? Yeah, the CH-3 rule. CH-3 rule. According to as a CH-3 rule we got, and what the CH-3 rule tell us that in an elimination reaction more substituted alkene is obtained as a major product. Look at the substitution pattern of this olefin. Here one alkyl group, another alkyl group and further alkyl group. So there are 3 methyl groups are there, and therefore it is called as a tri-substituted. And if you look at here, this alkene, only one side there is a substituents are present, and therefore this type of the, this is called as a tri-substituted, and this one is only as a mono-substituted over here. This one is a tri-substituted, this one is a mono-substituted. And so according to as a CH-3 rule, CH is a scientist name. He formulated the formula for an elimination reaction. What he says, what is his statement? He stated that in an elimination reaction more substituted alkene is obtained as a major product. That's it. And let us see how the mechanism, how this mechanism takes place over there. Here alcoholic KOH. Now if you see over here, first step, what is happening here, look at here a mechanism. Let us see as a mechanism over here. The mechanism takes place here like this, Br. Now this halide group, this is alpha atom and this is a beta, right? The halide group attached to carbon atom, that carbon atom is termed as a alpha and adjacent carbon atom is termed as a beta. Now when the KOH, as you know that it is a base, and look at here the hydrogen atom which is present over here, the OH minus can abstract the proton from here, that is a alpha, that is this one. Now when it abstracting the proton from here and it get form as a double bond, Br get eliminate, so that you are going to get as a this type of the product. And now when this proton get abstracted, but here what is happening, one of that proton available over here, this proton also can get abstracted, and we are going to get OH minus can abstract the proton from here, double bond is formed over there. So let us see first here what is going to happen. So here this is a, what we can call it as, here we got as a double bond, and now there is a one of the hydrogen atom, hydride get shifted, and this is a this hydrogen atom gets shifted forming as a double bond, and we are going to get, here is a formation of the double bond. This one is a major than this one, and due to that reason this is a major product. So in this way we can explain this. Now let us look at as a next example, example number 5 over here. So let's see here example number 5. Example number 5 here. So here example number 5, and what is that? By hydride shift, next one is a by hydride shift primary carbocation gets converted to secondary carbocation followed by loss of EH plus. Let us see here the example is given like this. The example is this one. So here OH is written over here. So this is what, and then this, that will be treated with concentrated H2SO4, and there is a elimination reaction takes place. Elimination reaction means what? There is a dehydration reaction means water molecule get eliminated from the starting compound. Can you tell me what would be the IUPAC name of this compound? You can give the number from this side: 1, 2, 3, 4 and 5. In the straight chain there are 5 carbon atoms and 2 is at 4 position there is a methyl group. Therefore we can call it as a 4-methyl 2-pentanol. So that is the IUPAC name of this compound. And as we know that there are 2 products are formed. One product is obtained like this. Here we are getting one product. Another product maybe as a this one. Here look at the product. 2 product we get over here in this example also. And now among these 2, which one is a major and which one is a minor? Again see the follow the CH-3 rule. What is that CH-3 rule? In an elimination reaction, more substituted alkene is obtained as a major product. Look at again here, if you observe the structure, what do you see? There are 3 substituents present. Therefore this is a tri-substituted. This is a major product and this is a mono-substituted. On one side that olefin is substituted and therefore it is called as a mono-substituted, and we are getting as a minor product. Why one we are getting as a, again there is a clear cut according to as a definition of that CH-3 rule. In an elimination reaction, more substituted alkene is obtained as a major product. Now again let me show you the mechanism, how the mechanism is taking place over here. So here this one, then OH, right? And as we know that in acidic condition, H plus is nothing but as a, you can write as a acid. H2SO4 produce the H plus, and as we know that hydroxy group, OH group get protonated, and we are going to get over here this one OH2 positive charge over there. And now when positive charge are there, it is get evolve very easily, minus H2O takes place, and we are going to get over here this one. Here is a positive charge. If you see this carbocation carefully, now tell me what kind of the cation it is, whether it is a primary carbocation, secondary carbocation or tertiary carbocation. Look at this attached to carbon, again carbon, therefore it is definitely secondary carbocation. Now if the structure permit, it rearrange into as a more stable carbocation. Now look at here, this carbocation can be this hydrogen, this hydride can be shifted from, there is a 1,3 hydride shift are possible over here, and this hydrogen atom can shift it from here to here. And what do you get over here? You are going to get, here is a carbon positive charge over there, and then this one. So that type of the, and what is this carbocation? It is a tertiary carbocation, right? And as we know that stability order, tertiary carbocation is more stable than secondary than the primary carbocation. This is a general trend or general stability order of that carbocation. Tertiary carbocation is always more stable than secondary than the primary. So in this way we can get this type of the product. Now let us look at another example, that is Wagner-Mervin rearrangement reaction. That is a very important one, and that is also proceeding via non-classical carbocation, that we know that. Now here remember, that is the example number 6 we are talking about, or we are discussing the reaction number 6 over example number 6, that is a Wagner-Mervin rearrangement reaction. Wagner-Mervin rearrangement reaction, and this Wagner-Mervin rearrangement reaction, that is proceeding via non-classical carbocation, and that we have seen yesterday. What do you mean by the non-classical carbocation? How this Wagner-Mervin rearrangement, it is one of the famous reaction, and generally the suitable example is considered over here is this one. Let us see here. This is a structure of this one type of the structure, and here this is a more substitute. Look at, here is a hydroxy group. When it is treated with H plus, what is going to happen? This type of the hydrogen get hydroxy group form as a carbocation here, but here 1, 2, 3, 4 groups are there. Which group is going to migrate over there? So that is the main thing over here, and generally, and when we are treating this compound, we are getting as a formation of the product. Let me give you the product here, double bond, and this one, I think this is a product generally we are getting. How we are getting as a this type of the product? Because here tertiary carbocation, here look at here this one, and hydroxy group, how the exo carbon-carbon double bonds are, how it is possible. So that's why it is known as a non-classical carbocations are there. Now let us look at as a mechanism over here, and when we see the mechanism, then and then we can able to see the how we are getting as a this type of the product over here. Let us see here the compound which we have drawn over here. There this hydroxy group present at equatorial position, there is a methyl group. Now when we are adding as a H plus, what is going to happen? The lone pair which is present on the oxygen atom will pick up that proton, and we are going to get over here this one. This is a structure generally. I am writing here is a H2O, positive charge comes on that, and now this bad living group is becomes as a good living group. Now when this is happening over there, they can form as an intermediate. Then after losing as a H2O, then this carbocation means this bond get migrate. So I am showing here is the intermediate is form over there. Now there is a numbering system generally followed here. 1, then you can go 2, then 3, then 4, 5, 6 and 7. Generally this is a numbering system is followed over here. So here again 1, 2, 3, 4, 5, 6, sorry, something is miss. 1, 2, then here 3, 4, 5, 6 and 7. Remember this one. And now when the transition state is formed over there, remember this one. So now let me show the transition state. Non-classical carbocations are formed here. How it is forming non-classical carbocation, which I am trying to show over here. Look at, this is a methyl group, and where from the hydrogen atom is going to break, and this is a dotted, this bond is going to migrate over there, and this bond is going to form, and so positive charge comes on it, and there is a this one. This is nothing but as a non-classical carbocation I am showing. This is a non-classical carbocation. Means if you see over here, this is 1, 2, 3, 4, 5, 6, 7 like this. So here how do you get? Here the numbering should be from this, from which side we are going to get again as a numbering. Here is a 1, 1, 1, this is a 1, 2, 3, 4, 5, 6 and 7. That is the numbering we are getting. 1, 2, 3, 4, 5, 6 and 7. Look at this numbering position over here. Here 1, 2, 3, 4, 5 and 6, right? And this one is a 7. Now if you give the numbering over here, 1, 2, 3, 4, 5, 6 and this is a 7. And after that what is going to happen? There is a loss of proton from here. Here I am writing for sake of convenience CH2H, right? This proton form over there, this bond is joined here. So look at how the situation is going to obtain over there. Now here I am writing as a very small arrow so that you can clearly see here. So here how do I get this one as it is? Then I am writing this one, this is as it is. This bond is going to form over there this way, and there is a double bond because it's lost over there, and this type of the compound we are going to get over there. So this is a 1, 2, right? 1, 2, 3, 4, 5, 6 and 7, and this compound we can write in this way. If you unfold it, it looks like this. This one, look at, this is a compound which we got. Here is a double bond, here this is there, and now number, look at here. So this is a 1 number, right? Here you refer, this is a 1 number. It is 1 joined to 5, right? Here we can write 5 joined to 6. This is a 6 number, and 1 there are 3 bond, 1, 2, 3. So this is a 2, and 2 joined to 3. So this is 3 joined to 4 joined to 5, 6 and this is a 7. This is a unfolded. So this is a numbering system you must remember while predicting the product. This is a non-classical carbocation, so it is a very, very important as far as this exam point of view is concerned, so that you can give the numbering system how we are getting as a this is known as a Wagner-Merwin rearrangement reaction. This is one of the example over here. Now let us move on to the next example, that is example number next example we are going to see over here, the addition reaction hydration of alkene. So that is the reaction we are going to learn over here. Let's see, first let me clean the board so that you can see the clear cut. Now is example number 7, addition reaction. Example number 7. Now is addition reaction. Addition reaction. In addition reaction, that is a hydration of alkene. hydration of alkene. Hydration of alkene we are talking about over here. So let us see here the example, this one, and double bond when it is treated with water H2O in presence of H plus, or it is sometime it is written as H3O plus hydronium ion. So what type of the product do you get over here? So after that, there you are going to get the major product is this one OH, that is a tertiary alcohol. How do you get that tertiary alcohol as a major product? If you look at the starting compound is this one, the IUPAC name of this compound 1, 2, 3 and 4. At one position there is a carbon-carbon double, 3 position there is methyl group, therefore 3 methyl, 1 butene you can call it as. This is the IUPAC name of this compound. And if you look at, if you see the product over here, 1, 2, 3 and 4. So at 2 position, the 2 position there is a hydroxyl group as well as methyl group also there. 2 methyl, 2 butanol. So that is a IUPAC name of this compound. But how do you get this? Let us see the mechanism over there. By looking at the mechanism, we can clearly find out how we are getting this one. Now let us see over here, this one, double bond. H3O plus means here is a H and OH we can write like this. So this is going to attack on that, and OH, the what we can call it as a leaving group. So that we will get over here, this one, there is a positive charge. Now the hydrogen atom which is present over there, this shifting from, there is a 1 to hydride shift. After shifting that, we are getting here this one positive charge over there, and after this OH minus, it is going to attack over there, and you are going to get the tertiary alcohol like this. So in this way we can very easily predict, because all these reactions are taking place via carbocation. So this is there. Now let us see one more example, reaction involving alkyl shift. So that is the next one, the example number 8 we are learning over here, we are discussing over here. Let's see the last one, example number 8. That is what is that? Reaction involving alkyl shift. Reaction involving alkyl shift. Reaction involving alkyl shift. So here how do we can, let us see, here is the example of this one. Then I think OH, this is the example, and this one is treated with HBr, that is a bromide. So what would be the IUPAC name of this compound? You can give the number from this side, 1, 2, 3 and 4. Look at 3 position, there is a 3,3 dimethyl 2-butanol. This is the IUPAC name, and the product which you are going to get, the product will be as this one, Br, and this is the product, the name of that product will be the 1 methyl group here, 1, 2, 3 and 4, that is a 2, 3 dimethyl 1 bromo. The IUPAC name of this comma, I am thinking about that one. So at 2 position, so 2 bromo, then 2,3-dimethyl 2,3-dimethyl butane. So that is the IUPAC name of this compound. How we are getting that one? Let us look at as a mechanism. Once again, you write down this structure as it is OH. Then as we know that HBr is acid. After acting over there, Br get eliminated. Br is a living group, so that we are getting this one. Then OH2, this becomes as a good living group, and then it after elimination of that water molecule H2O get eliminated, what you are going to get over here? This methyl group. Sorry, here we are getting as a positive charge over there, and after that this methyl group is shifted from here to here, and what you are going to get after shifting that one? Positive charge coming over there like this, and now then there is an attachment of Br at this position, and we are going to get the final product is this one, Br, and this one is 2. Got it? So in this way we have seen all these reaction involving as a carbocation. In the next time we will see mechanism involving nitrene, that is acyl nitrene to isocyanide. I think with this let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.